Hydrocarbon. Part 2. Alkene, Alkenes, and Alkyne. Alkanes. Alkanes are acyclic branched or are branched aliphatic hydrocarbon having one carbon-to-carbon single bond, and thus the general molecular formula is CnH2 This is the example of alkanes, and it has single bond. Also, it has single bond. Nomenclature of alkanes. If alkane only has one C, it called methane. It has two C, it called ethane. Has 3C, it called propane, and it has 4C, it called butane. It has 5C, it called pentane. It has 6C, it called hexane. It has 7C, it called heptane. It has 8C, it called octane. It has 9C, it called nonane, and it has 10C, it called decane. Alkyl. Alkyl is alkenes that missing one hydrogen. Alkyl is one of the substituents that connected to the main of hydrocarbon chains. The general molecular formula is CnH2n-1. This part is the alkanes. And then this alkene remove H and it become alkyl. Nomenclature of alkyl. When it has only one C, called methyl. When it has 2C, it called ethyl. When it has 3C, it called normal propyl. As you can see from this picture, this is the straight chains without branches, and it called normal propyl or N-propyl. And this is the propyl, but the long chain connected with C secondary C. So it called isopropyl. It has, from this picture, it has 4C without branch or without more substituent. So it called normal butyl. And this is a secondary butyl because the C is connected to the secondary carbon. And isobutyl when C connected to the primary C, and then tertiary butyl when is butyl with connected to the C tertiary. This is C tertiary. Naming alkanes. Rule number 1. Find the longest carbon chains. Rule number 2. Number the longest chains starting at the end closest to the substituent. So this is the structure of alkanes. And this is the longest carbon chain. Number the longest chain starting at the end closest to the substituent. Because this end close to substituent and this end close to substituent, you can start the number from this end or from this end. And this is the substituent, or we call it branch. Rule number 3. After numbering the longest chain with the lowest number assigned to the alkanes, Label each of the substituent and its corresponding carbon. So this is the substituent, which is corresponding carbon. This substituent connected to C number 2 of the main chains. This substituent connected to C number 3 of substituent of the main C of the main carbon, and this substituent connected to C number 4 of the long chains. Rule number 4. While writing out the name of the molecule, arrange the substituent in alphabetical order. If there are more than one of the same substituent, use the prefixes T, 3, and tetra for 2, 3, and 4 substituents respectively. These prefixes are not taken into account in the alphabetical order. Because it has 3 substituents of methyl, we can name it 2, 3, 4, 3-methyl pentane. Pentane because it has 5C. Alkenes. Alkenes are acyclic branched or unbranched aliphatic hydrocarbon having 1 carbon-to-carbon double bond, and thus the general molecular formula is CnH2n. This is the example of Alkynes chain. It has double bond. Nomenclature of alkenes. When alkene has 2C, it called ethene. When alkene has 3C, it called propene. When alkene has 4C, it called butene, 1-butene. Or when alkene has 5C, it called pentene. When alkene has 6C, it called hexene. When alkyl has 7C, it called heptene. And when alkenes has 8C, it called octene. And when alkene has 9C, it called nonene. And when alkyl has 10C, it called decene. And this is the number that the atom C up to 10. Naming alkenes. Rule number 1. Find the longest carbon chains that includes both carbon of the double bond. Rule number 2. Number the longest chain starting at the end closest to the double bond. This is the example of alkenes. This is the longest chains. We start the number from ends that close to double bond. So we start to number this chain from this end. 1, 2, 3, 4, 5. Rule number 3. After numbering the longest chain with the lowest number assigned to the alkenes, label each of the substituent at its corresponding carbon. This is the substituent. Substituent located at number 4 of main C chain. So this structure named 4-methyl because this substituent is methyl, 2-pentane. Why 2-pentane? Because the double bond is on number 2 of the main chain. Rule number 4. While writing out the name of the molecule, arrange the substituent in alphabetical order If there are more than one of the same substituent, use the prefix D, 3, and tetra for 2, 3, and 4 substituent respectively. These prefixes are not taken into account in the alphabetical order. So this is the example that the chain has more one substituent. The first one, we have to determine the long chains, the longest chains. It has 1, 2, 3, 4, 5 C, and the double bond located at number 1, and the substituent located at number 2, C number 2, and C number 3. The name of substituent is methyl. And what's the name of this structure? The name is 2.3 dimethyl 1-pentene. Why 2 and 3? Because the substituent located number 2 and number 3. And why dimethyl? Because there are 2 methyl. And why 1-pentene? Because the double bond located at number 1 of the long chain. Rule number 5. When there are 2 double bonds in the molecule, find the longest carbon chain including both of the double bonds. Number the longest chain starting at the end closest to the double bond that appears first. The suffix that would be used to name this molecule would be "-ine". This is the structure of alkene that has 2 double bonds. This structure has 5C and the double bond located at number 1 and number 3. This structure has branch or substituent at number 2, and the name of substituent is methyl. So the name of this structure is 2-methyl 1.3 pentadiene. Why pentadiene? Because it has 2 double bonds at the long chains of alkenes. Penta means it has 5C of chains. Alkynes. Alkynes are acyclic branches or unbranched aliphatic hydrocarbon having 1 carbon-to-carbon triple bond, and thus the general molecular is CN2H2-N-2. This is the example of alkyne structure, and this is the triple bond of alkyne structure. Nomenclature of alkyne. This is the nomenclature of alkyne. If the alkyne has only 2C, it called ethyne. If it has 3C, it called propyne. When it has 4C, it called butyne. When it has 5C, it called pentyne. When it has 6C, it called hexyne. When it has 7C, it called heptyne. When it has 8C, it called octyne. When it has 9C, it called nonine. When it has 10C, it called decyne. Naming of alkyne. Rule number 1. Find the longest carbon chain that includes carbon of the triple bond. Rule number 2. Number the longest chain starting at the end closest to the triple bond. So this is the example of the alkyne structure. This is the longest chain. Okay, we can start the number from the ends that closest to the triple bond. So we start from this end. Rule number 3. After numbering the longest chain with the lowest number assigned to the alkyne, label each of the substituent and its corresponding carbon. This is the structure of alkyne. This is the longest chain of alkyne structure, and this is how we numbering the alkyne start from the end that closest to the triple bond. And this is the substituent. The substituent located at number 4, C number 4. And the structure name is 4-methyl-2-pentyne. Why 4-methyl? Because the substituent located at C number 4 and the name of the substituent is methyl. And why 2-pentyne? Because the triple bond located at C number 2 of this long chain. Rule number 4. While writing out the name of the molecule, arrange the substituent in alphabetical order. If there are more than one of the same substituent, use the prefix D, 3, and tetra for 2, 3, and 4 substituent respectively. These prefixes are not taken into account in the alphabetical order. This is the example of alkyne structure. The triple bond located at C number 1. So, we get the number of this structure from the lowest C number 1, which closest to the triple bond. And this is methyl and methyl located at C number 3 and number 4. This structure has the long chains with 5C. So this structure named 3 and 4 dimethyl 1-pentyne. Why 3 and 4 dimethyl? Because the substituent located at number 3 and number 4 of the long chains. And why 1-pentyne? Because the triple bond located at C number 1. Rule number 5. When there are 2 triple bonds in the molecule, find the longest carbon chain including both the triple bonds. Number the longest chain starting at the end closest to the triple bond that appears first. The suffix that would be used in the name this molecule would be diene. Okay, this is the structure of Alkun. As you can see, it has 2 triple bonds. Because this triple bond located at both at the end of these chains, so you can start the number from the left or from the right is the same. Okay, so the name of this structure is 3-methyl 1.4-pentadiene. Why 3-methyl? Because it has substituent methyl that located at number 3. And why 1.4-pentadiene? Because the triple bonds located at C number 1 And C, number 4. Rule number 5. A molecule that contains both double and triple bond is called an alkyne. The chain can be numbered starting with the end close to the functional group that appear first. It has two part of bond. The first bond is triple bond and the second bond is double bond. Exercise 1. What is the name of this structure? That's right. 2 and 3 dimethyl butane. Exercise 2. What is the name of this structure? That's right. 3.3 dimethyl pentadiene. Exercise 3. What is the name of this structure? Five methyl and 1 hexane. This part should be triple bond and it only has CH. The uses of hydrocarbon compounds. The uses of alkanes, gasoline, isooctane and normal heptane is part of alkane. Liquid petroleum gases. Methane, ethane, propane are part of alkane. Asphalt, long chains that has 35C atom. The uses of hydrocarbon compounds: alkene, plastic, ethene and or ethylene for polyethylene, to the raw material to make a plastic bag. Household, propene for propylene is part of alkene. Synthetic rubber, butadiene for polybutadiene for alkenes. Third, the uses of hydrocarbon compounds, alkyne. Third, that is C2H2 that we use to burn metal, or we call it acetylene. Synthetic rubber. Neoprene is a non-natural rubber that does not burn or get taken on by oils. Terpenafine is the rash ointment. Thank you.